Hello friends, this video Limits and Derivatives Part 13 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 12. In this example, we have to find the value of a and b where the function is given f is equal to a plus b for x is less than 1 is equal to 4 for x equal to 1 and b minus ax for x is greater than 1. Also, we are told that this limit of x tends to 1 of fx is equal to f. So that means we can say that for fx, the left hand limit is equal to the right hand limit and this is equal to 1. Correct? This is what we can say, that the right hand limit of this function at x equal to 1 is equal to the left hand limit of this function at x equal to 1 is equal to 1. So first let's find the left hand limit or right hand limit. This right hand limit x is tending to 1 plus. So that is, we can say that limit of x tends to 1 plus of fx. So 1 plus is this function will use is b minus a into 1, that is b minus equation 1. Similarly, right hand limit, the left hand limit for this function will be, in this case we use this function because this is less than 1. This will be a plus b into 1, that will be a plus b. This is equation 2, correct? And value of f1, so value of f of 1 is nothing but 4, that's the equation 3. So all these 1, 2 and 3 are equal. So we can say that b minus a is equal to a plus b is equal to 4. So we have this thing, this is equation 4. Now we'll take these two. These two will take, so what we get is b minus a is equal to a plus b, b we cancel, or we get 2a is equal to 0 or a is equal to 0. So we have got the value of a. Now we'll use these two equations. So here it says a plus b is equal to 4. A is already 0, we know that 0 plus b is equal to 4. So we can say that b is equal to 4. So we have two values, b is equal to 4 and a is equal to 0. That's our answer. Very simple. We were told that the left hand limit and the right hand limit and the value of the function at f is equal to 1 are equal. So we have found the values of left hand limit, right hand limit and f of 1 and we have equated to get the answer. In this example, we are told that there is a function. Its value is x minus a1 into x minus a2 into x minus a3 into x minus a4 equals to x minus an. And we have to find the value of this function, limit of fx, where x is tending to a1. To do that, we'll just put x equal to a1 and we'll see if it is not infinite, then that is the value. So we'll say that limit of x a1 fx, we'll try first f of a1. So this becomes a1 minus a1 into a1 minus a2 dot 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 a1 minus a1. And this becomes 0 because this is 0. So this is a valid value. So we can say that f of a1 or limit of f function where x tends to a1 is 0. That is the answer. This is the value. Also, we have to find the limit of this function where x tends to a. Now the second part, limit of this function where x tends to a. What we can do here is, we'll again put the value of x as a and we'll see if this becomes finite or not. Or if so this becomes nothing but, we'll try with f of a. This is nothing but a minus a1 is 1 into a minus a2 into a minus a3 dot 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 a minus a. So we see that this value is finite because a is not equal to a1, a2, a3. So we can say that this is the value and this is the answer. So we can say that limit of fx, x tends to a is nothing but a minus a1 into a minus a2 into a minus a3 dot 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 a minus a. So you see this question looks complex, it looks very big question. It's a very simple question actually. See, the very first step we do is we first try to put the value. For example, limit of x tends to a, we'll try to put the value of x equal to a in the function, and if we see it is finite, that means that is the answer. So here we have, when we have put x equal to a, we have found that the value came out to be 0, that's a finite value, and when we have put the value of x equal to a, we also find that the value came out to be finite. So that is the answer. So we didn't manipulate our equation. Here we have to find the values of a for which this limit fx extends to a exists for this function. So we have three options. One is a is equal to 0, a is greater than 0, and a is less than 0. So you can have three values. So first we'll try to check whether for a is greater than, because this function is of this form, a is 0, greater than 0, less than 0, that means this function breaks at 0. So we'll try to find the value, whether the limit exists for a at this point. So first a is equal to 0. So for a is equal to 0, if you see the left limit is x tends to a minus, or a tends to 0 minus, x tends to 0 minus, x tends to 0 minus, what we get is, this becomes, we'll use this equation, so this becomes 0 mod plus 1, that is 1. So in the right limit, if you see, this will be x tends to 0 plus of fx, this will become mod of 0 minus 1, this is minus. So if you see, left limit and right limit are not same, So we can say that at x is equal to 0 or at a is equal to 0, this, for this function, this limit doesn't exist, because when I say a is equal to 0, the left limit and right limit is not same. Now, case 2, a is equal to 0. This is a is equal to 0. In this case. So for this case, the left limit, that is x tends to a plus, because a is greater than 0, a minus. So here we'll use this equation only, because this is always greater than 0. So this becomes mod of a minus 1, correct? This becomes a minus 1. Similarly, right limit for x tends to a plus will also be, we'll use the same equation only, because here a is greater than 0, right? So this will becomes a minus 1, this becomes a minus 1. So we see that both are same, correct? So we can say that limit x tends to a, fx for a is greater than 0 exists. Similarly, for a is less than 0, and you want to find the left limit, x is greater than, left pointing to a minus, you have to use this equation, because a is now less than 0. This becomes mod of a plus 1, and that is a plus 1. So the right limit, if you want to find, that becomes x tends to a plus. So here also we use the same equation, right? So this becomes a plus 1. So we see that the values are same. So we can say that at x is equal to less than 0 also, the limit exists. So we can say that for all values of a except a is equal to 0, the limit exists, correct? What we have done, we have seen that this equation breaks at x equal to 0. So we have got three conditions: a is equal to 0, less than 0, and greater than 0, and less than 0. Then we found that if you take a is equal to 0, in that case, this becomes 0 because this is a. So left limit and right limit is not same. But when you assume a is greater than 0, in that case, left limit and right limit are same. When you assume a is less than 0, there also left limit and right limit are same. Thus, we can say that for this equation, the limit exists for all the values of a except x equal to 0. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.